inspect all the conditions of transformer, oil temperature, winding temperature, as well as the VCP conditions, CT conditions, LA conditions, as well as all the internal conditions of the substation. Remote control and the data acquisition and supervision, we can do this SCADA. And that is the block diagram we keeping over here. And that will explain later on. Because of the time constraint, I cannot go it in detail. And that is the remote operation, how we'll do. It is given over here. Even we can change the tap through OLTC, we can change the tap of the transformer to a SCADA operation. And what are the reports we get? Then substation daily load, substation log sheet, substation energy level, kilowatt hour, RKVA, interruption, CB tripping, monthly reports we can create also, and daily reports we also can generate. That is how we usually. SCADA is a separate subject. There is maybe 2 to 3 hours it takes to explain how we can operate the SCADA and all through softwares and everything. With all, I think I finish up my lecture. Thank you so much for your patient hearing and helping us to give my experience and to share my experience to you all. Thank you very much, and over to the host.
Thank you very much, sir. Your session was very informative. Through your slides, we have virtually visited, it seems we have virtually visited the substation. We have seen so many things that many of us can see in industrial visit. Many of our students have seen, they could relate with it. Thank you very much, sir, for this wonderful presentation. We have our Dean Academics, Ashok Shah sir, with us. So I would request Dean sir to present vote of thanks to sir on behalf of RERF.
Am I audible?
Yes, sir.
Yes, sir. Yes, sir, you are audible. Thank you so much, sir.
Good evening. Good evening, Partho sir.
Thank you. After so many times, I think I have seen you.
Again, we will have to meet. Again, we will have to meet many times in our campus physically.
Thank you so much.
In future.
Thank you so much, sir. Kind of you, sir.
Yeah. So, on behalf of Regent Education and Research Foundation group of institutions, it is my pleasure to convey my regards and thanks from bottom of my heart to Mr. Parthopratim Datta, who is such an eminent personality in West Bengal and in India that no introduction is required. Still, it is our formality. We will have to say something about his profile. He is energy auditor and additional C and zonal manager of Bardhaman zone of WBSEDCL. And he has been such an outstanding student in his student life also. And sir, I would like to thank you. So that you have given us so much time from your such a busy schedule. I would also like to thank Principal Madam of Regent Education Research Foundation group of institutions, Dr. Mahuba Das, HOD, Professor Vidyut Kumar Ghosh, and Professor C. Raj Lakshmi, and Professor Mrinmoy Das. Without their help and coordination, this was not possible. And all other faculty members and staff of electrical engineering departments. I would also like to thank professors, teachers, staffs of other departments of our college and other college and other universities staffs also. I would also like to thank the students and the faculty members and the participants for their patience, hearing, and participations. Sir, a few points I would like to point out from your presentation today in brief. Sir, today you discussed and presented design and maintenance of 33 by 11 kV substation in power station system network. You just step by step presented the design selection, part from civil engineering point of view, and also from electrical design, electrical point of view. You discussed design of earthing system, design of station service transformation, design of AC, DB, DC, DB, battery and battery charger. Sir, you also discussed design of 11 kV outgoing feeders, design of earth mast of lightning protection, design of protection system of 11 kV feeders, and also you discussed selection diagram for switch yard for 33 by 11 kV substation. You also discussed SLD for typical substation. You also discussed instrument safety factor, accuracy limit factor properties, and insulating oil also. Insulating from three point of view: physical, electrical, and chemical. You also suggested testing of transformer like TTR, DCP, core balance test, magnetizing current test, etc. You also discussed sample test result of core balance test, polarization index, etc. Special test also you discussed. Oil BDV test you discussed. You also discussed measurement of voltage ratio, vector, group verification test, etc. Separate source of voltage, etc. Sir, you also showed some case studies also. Calculation of fault current for earth mast design, step and touch potential also. You just showed power transmission protection over current protection, earth fault current differential protection scheme. You showed the very important diagram of Bachelor relay with constructional details, pressure relief device operation, etc. And at last, due to some lack of time, you briefly summarized RGU daily and monthly reports, these things. Sir, again, there will be no scarcity of time in our campus. In future, we will have your presence, physical presence also in future in our campus, and that we will want it will be frequent visit to enrich our students, faculty members, and all other staffs. Sir, so for this, I would like to thank you very much, so that you have given us your so much valuable and precious time from your such a busy schedule. Thank you, sir. Thank you very much.
Thank you so much. I just put my heartfelt thanks to everybody, especially Raja Lakshmi ma'am, all the students, Professor Ashok Kumar Shaw sir, and Vidyut, especially who has arranged all these things. Especially I want to put my heartfelt thanks to Regent Foundation also, who has given me the chance to present our experience. Definitely, I am very much keen, and some questions are there. I will definitely, somebody has asked me that why stones and pebbles are used in the substation. Usually,
Yes, sir.
we use stones
Before
and pebbles.
concluding, okay, sir. There are many questions, sir. If you permit, then I would put forward.
Yeah, definitely.
The first, somebody has asked. Some of our participants have asked. Electricity transformer in electricity transformer frequently there is.
There is, I think, voice is cracking. I can't hear properly. I think maybe some.
Somebody is. Sir, can you hear me now, sir? Hello, sir.
Hello.
Can you hear me now?
Some
Sir.
sounds are coming. Sounds are coming over. Maybe somebody is in street. Who is in street? Maybe he may be requested
we'll try
to put. Yeah. Thank you. Now
Yes,
it is
sir.
clear.
Yes, sir. So there is a question like why in 11 kV transformer frequently we have earth fault?
Because of you see the in 11 kV transformers we see 11 kV by 0.5 415 volt transformer. So usually 415 volt transformer. We see that there is star connected LV side. So there are 3 phase RYV as well as the neutral. And you see in the, it is the LV sides, all the watts, the LV watts, the 415 watt, what is LT watts, we usually tell it. It goes through the roads or any para or any streets. So in that case, when it comes around, any storms happens or any sort of you see the branch of the trees or something falls upon the line, so it snaps and it falls on the street. When it falls on the ground, the earth fault happens. That's why frequently we see the earth faults in the 11 kV, I think 11 kV transformer. Another point is, it touches any parts which is grounded. When the live wire touches any part which is grounded, so then the earth fault happens. As because it is exposed too much to the outer world, it is not only limited to the substations. So in 11 kV side, we usually experience the earth fault too much rather than to other substations or EHV system.
Okay, sir. And now the next question is, why gravels or stones and pebbles are used in substation?
Yeah. Why? Because you see, when we have shown you in our presentation that usually when there is naked earth in the substations, their step potential is much higher, and when fault currents happens in the earthing system, if it is not suffice to limit the step potentials, the persons may go fatal. In that case, to reduce the step potential, pebbles usually creates the resistance levels so high, so that the step potential be much lower when you use pebbles. That's why pebbles we are using to reduce the step potential as well as the starch potential of the substation.
So there is another question, like, are there any plans to upgrade substation with new technology formations in near future? And will that replace all these existing designs?
We have already discussed that in Barakpur, also very nearby to Region Foundations College, there is a substation of GIS substations, which is I think is a design of its own. In entire India, there are 5 such substations. One is in West Bengal, that is in near Barakpur. That is GIS substation in 30 kV side. Entire 30 kV switchyard is being placed in one box through GIS environment, and as well as I have shown you that we are also going for the SCADA